Hello, learners. Hope you are keeping well. My name is Rajendra Dave Chan, Dave, and I will be doing your geography presentation today. Now, learners, as you know already, this session you can actually contact us via WhatsApp if you have any queries, challenges regarding the geography, and that specifically is on geomorphology. So the WhatsApp number that you must actually contact us on is 079 578 2908. I'll repeat that, 079 578 2908. And my colleagues, Rina and Portia, are ready to answer those challenges that you have and sort them out and get them ready. Get you ready, rather, not them, for the papers that you are writing. Learners, I hope things are going well. And I just want to emphasize again, I hope you are learning smart. And smart learning means whenever you study a section, then you take a recent past paper on that section, sit down under exam conditions, and then you write it. If it's for an hour, you write it for an hour. And that is smart. Go over the memo and check whether you have what you've got right. And suddenly you find any challenges, immediately sort it out. Study smart. Today's lesson, learners, is on geomorphology. Okay, we're going to review the section, look at summaries of each section. And as I said, if you have any challenges, we will come to you, or you can send it on WhatsApp. Now, I'm looking at the simple approach. And one of the things when I'm going through this presentation is emphasizing the point, don't learn things in isolation. Try and link things so that it makes it easier to study, and it also gives you a better and smart understanding. But I will go through it and I will make that clear when we go through the session of how we can also link things. So let's not waste more time and get on with the show. Okay, now I want to emphasize this first little section here. You will notice that when we talk about drainage basins, there's a whole lot of concepts. In fact, it goes further. Drainage basin, catchment area, river system, tributaries. So there's a lot of concepts, and this seems like a lot of studying to be done. Look at summaries. Let's link section. Let's make it simpler. Remember the simple approach that I've always spoken about in all the little presentations that I've done. Now, let's take this and make it simpler. All right. Now, if I had to study this, I'm going to link them. And I will look at this, and I will take this little slide here, because all these features are related. If I look at the issues here, and I'd like to start off with the watershed. Okay? And if I look at this little point here, I'll see it's a high-lying area separating two river systems. So I have a river here, as you can see, and on the other side of this high-lying area, I have another river. So if you can visualize the Drakensberg, okay, because you in Gauteng, you can realize the Drakensberg mountain range, and on one side, you've got the Tugela River on the KZN side, and then you have the Vaal River on the Gauteng side, and you have the high-lying mountain range in between. So visualizing the thing makes it easier. So watershed is a high-lying area separating two river systems. Okay, then we have the draining area. When it rains or there's precipitation, it captures the water. All right, and that is your catchment area. So the watershed divides the river systems. The catchment area then captures the rainfall. Now let's take the next step. What happens? This water gets captured and starts draining into the river. Can you see it and its tributaries? So then we come to the drainage basin. this area, the area drained by a river and its tributaries, already you're seeing the relationship where the watershed, catchment area, drainage basin, all right? The area drained by a river and its tributaries. Obviously, what's the river and its tributaries? It is the river system. All rivers or stream channels in a drainage basin. So this river system then drains the water. Okay? Now, in the river system, we also have tributaries. All right? Is a smaller river that joins a larger river. Can you see it there? The smaller rivers joining the larger river. All right? So that is your tributaries. Then you will pick up that these tributaries, they meet at a point, or the tributary meets the main stream at a point. That point where they meet, and that is your confluence, is a place where the two or more rivers meet. Can you see the relationship, learners? And if you're learning it like that, it makes it so much easier. Okay, so where the two rivers meet, that's your confluence. Now, for us to have two tributaries separated, there has to be a highline area in between. Otherwise, the rivers won't be separated. And then we come to our interfluve, a highline area separating two streams of the same river system. And that is your interfluve, right? That we have there. So you can see the interfluve that is separating the two tributaries. But obviously, when you're studying this, you must be cautious, because sometimes people mix up the watershed and the interfluve. So remember, your watershed is a highline area separating two river systems, all right? But your interfluve is a highline area separating two streams of the same river system. So this is one river system, and this highline area is separating two streams, whereas this separates two separate river systems like the Vaal and the Tugela rivers. Okay, and then we've got surface runoff, the water that actually flows on the surface, as shown there. Then, of course, you know, where the river starts is the source, as indicated here, and where the river enters the sea is the river mouth. Can you see it? When it ends into the sea. Obviously, you got one more, groundwater, all right? And this is the water that is found underground. It sinks into the ground, all right? It soaks into the ground. It infiltrates and flows in the ground. So learners, can you see how we took this and we showed a relationship between the points? And in that way, it actually makes it easier to study. Okay. And try to do that with all your sections. As I showed you in that presentation on human geography, you can relate that also in terms of that. All right. Now, types of rivers. And I want to teach you another skill here, learners, when we study. I know some learners, you ask them, what is a permanent river? Oh, it's a river that flows throughout the year. And when you ask why is it a permanent river? Not because it flows throughout the year. And we need to make sense when we study of what causes. And remember, geography is the what, the why, the how. You understand? We need to ask those questions, because higher order questions, as looking at past papers, wants to ask these things. They want you to take it further. And where you just get a definition or a listing from past papers, we notice it's just a few marks, but that how and why and explain how, explain why seem to be carrying more marks. So it's not just learning your work, but making sense of it. Okay? So let's take this permanent, periodic, episodic, exotic, and try and see the reasons, the why factor. All right? And then after that, we'll look at the drainage patterns as such. So let's see and make sense of that. Okay, I've taken these rivers and put it with the water tables. So let's make sense of the water tables. We have a wet season water table, and it only contains water during the rainy season. When it's not raining, there's no water at that level. Okay, let's take the dry season water table. This has water throughout the year. So here it's in the rainy season, here it's throughout the year. So I want to look at this and I want to say, I know what's a permanent river. It flows throughout the year. Now we want to get into the why factor. If I look at a permanent river, it cuts the wet season water table and the dry season, meaning that if it cuts the dry season, it will have water throughout the year. Can you see the reasoning now, learners? Then we take the periodic river, and it says it flows during the rainy season. Now let's look at why. This periodic river does not cut the dry season water table. It only cuts the wet season water table. And what is the wet season water table? It contains water during the rainy season. So you're not going to have this river flowing during the rainy or the dry season rather. Then the episodic, it flows after heavy rainfall. Why? Because it cuts no water table, if you can look at here. It doesn't cut the wet or the dry season. So it has to rain, water has to soak in, it has to saturate, or when it's heavy rainfall, it just floods. There's not enough time to infiltrate, so we have flooding and it flows. So we can see why these things are there. Okay, right. Now, let's look at the exotic river. It says an exotic river starts out in a humid region and flows into a dry region. Okay, the river flows throughout a desert and can be considered exotic in its existence. And it's the source of water allows for the river to flow throughout the dry areas and throughout the year. So what I'm saying here is that this is the area where rainfall happens. Let's say in the Free State, right? I'm using the Orange River, which is a permanent river, which flows throughout the year, but it also flows through the Namib Desert. All right. So this is your Free State where you've got water supply coming down here. Okay. Now this river, if you look at it, it flows from the Free State across to the west. And of course, your desert is there. So there's enough water to carry this river across towards the west. Okay. And that's what makes it exotic, because there you have a desert region and you have a lovely river flowing through, even like the Nile River. It's exotic. It doesn't seem to be part of that area. It's unusual to have a desert with such a nice river flowing, and it flows throughout the year. Okay. Right, so that's your exotic river. Now, I want to come to drainage patterns. Okay? And what we look at basically with drainage patterns, we look at number one, characteristics. All right? Apologies again for my writing. Characteristics. Okay. We look at underlying rock structure. Right? Rock structure. Okay. And as we looked at your prelim papers, it also looked at the amount and density it covers. Okay. So density in terms of your drainage density that it covers. Okay. So let's look at these drainage patterns. So I'll look at each one, I'll try and put them in. Okay. So when I look at this one, the dendritic pattern, I see that it resembles branches of a tree. The tributaries join at acute angles. These are characteristics. And it forms in uniform rock structure. Rock structure that actually has equal resistance across. That's the underlying rock structure. So branches of a tree, acute angles, underlying rock structure is uniform resistance. And because it has a uniform resistance, we find streams spread out in the area. So generally, if it's softer rock, etc., you may have an even spread of streams in the area. Okay, then we look at the rectangular. And what do we notice here? The main stream has 90-degree bends. Remember, I'm emphasizing the main stream has 90-degree bends. Okay, why do they have 90-degree bends? Because the rocks below has, the structure is jointed igneous rocks. So if I had to create joints here, like that, all right, because the rock is jointed, it has cracks. And if the main stream has to flow, it will flow within those cracks. And can you see the 90-degree angle, all right, of the main stream? So everything has a reason. Okay, I'm going to skip to trellis next. All right, the main streams are parallel and tributaries join at right angles. If there's mainstream, if there's two mainstreams. Now, what would make it parallel? Or the main factor is the tributaries joining at 90 degrees. So, if I look at the underlying rock structure, it's folded or alternate layers of hard and soft rock. So if my area has folds and my river flows there, okay, remember when we have folds, we're going to have a valley and a spit. Okay, so what happens now? When the river flows down the steeper slopes, it's going to have energy. Okay, and it's going to flow straight. And because of those steep slopes, it flows straight down and joins the main stream at right angles. Can you see the idea of this? Everything has a reason. Don't just learn it joins the main stream at right angles. Learn why it joins the main stream at right angles. Let's take your parallel. Okay, a parallel pattern which is caused by steep slopes and some relief, example ridges. Now, if I have a ridge, you know what's a ridge? It's an area like that. Okay, and of course, if I have a ridge here, and a ridge here, and a ridge there, what's going to happen? The streams are going to flow along that ridge on both sides. And because they flow along that ridge on both sides, it creates the parallel streams. Okay? And of course, the last one I have on this one, there's two more to come, is deranged. And here we talk about glaciation, when those glaciers, those ice pieces that just move, they move in any direction. You understand? So therefore, it does not have no specific pattern. It just goes, if you look at here, there's no clear pattern. Here you'll notice the streams are parallel. Here you'll notice they meet at right angles when you tell us. Here there's no pattern. Okay? Right. And then, of course, we have our radial. And learners, please look at your guideline. We are aware that the radial pattern radiates outwards. Can you see it here? It's going outwards. All right? Like a spoke of a wheel, it's just going out of a bicycle. All right? So there's a high-lying area, okay, a central high-lying area, okay, and it moves down like a dome. You have a dome there, and it moves away from it. So it's radial. Now, yes, it's like a centrifugal sort of movement away. Please, the pattern is radial. Okay? That outward movement is sort of centrifugal. It describes the pattern. So if you just write centrifugal pattern, you're not going to get the mark. The main word is radial. So it's important to look at your guideline. Okay. And of course, we got the centripetal pattern where it moves inwards. And this could be a basin where it goes into an area, right? When rivers discharge their water from all directions in a lake or depression or crater, so they move inward. So it's radial when it moves away from a dome, and centripetal when it moves into a basin or a lake or anything that's more basin shaped. Okay, I think we've created clarity with that. Okay, some examples here, learners. I know you guessed it already. Let's look at this pattern, because your work can be tested in map work. And what do I notice here? Yes, there's the main stream. And if I look at the tributaries, and can you see it's in the valley and it's steep slopes around it? Can you see the steep slopes? And there's the mainstream, tributaries joining the mainstream. And because of the steep slopes, they are joining at right angles. Definitely a trellis pattern. Oh, what am I seeing here? There's a cop here, a high-lying area. And what do I notice? It's moving away from the high-lying area. Can you see that? Right, it's going out. So clearly, that's my radial. Can you see that? Oh, what is this? Let me see down here. Oh, there's acute angles. The river is joining at acute angles. Can you see the acute angles? And it resembles branches of a tree. So that is dendritic. And if I look at this, I can say, what is the underlying rock structure there? It's uniform resistance. Can you see it? What is the underlying rock structure here? It's folded or alternate layers of hard and soft rock. And we can look at these things because we know the pattern, right? We know that we identify it through the characteristics. We can then determine the underlying rock structure. So it's very, very interesting that we can look at so many things, eh? And of course, don't forget, when you're studying, learners, it's so important to look at map work in relation to theory. All right. And of course, know geomorphology has a lot of features and things like that that can be found on a map, and you can see it. So when you're studying, take out a map. If you don't, I know schools don't, you can go to your teacher, sit in the class, take out a map and go through it and link it to your theory like I have done. Okay. Then drainage density. Of course, I've had this medium high, but the guideline stipulates low and high density. Okay. But this just gives you an idea of what drainage density is. We have to look at the guideline. It says low drainage density and high. Of course, what is drainage density? The total length of all streams per unit area of basin. Right. I can't say the density is high if the unit area is not the same. If I have this, learners, can you see there? And the size here, it's the same. Now I can do a comparison because one area is not bigger than the other area. And if I look at the comparison, because blocks are the same, I look at the total length of all the streams here. If I had the total length here, it's far less than there. Can you see it? So the drainage density is lower here and it's higher there. Okay? Because there's more, the total length of all these streams per unit area is higher. So there's a high density and a low density. Of course, we look at, that clarified the definition of drainage density. Of course, we look at various factors. And I'm just going to look at it summary form. You'll have to take it further as you discuss. Okay, precipitation. Obviously, if there's more precipitation, there's a higher density because if there's greater volume of water flowing, it will cut more streams. Am I right, learners? I can see you shaking your heads there. All right, soil moisture. The more soil moisture, the higher drainage density. Now, you may wonder how. Because if there's more soil moisture, the ground can absorb less now. So what happens to the rest of the water? It flows on the surface, cutting more stream channels. Vegetation is different. If there's more vegetation, there's a lower drainage density. Why? What does vegetation do? It slows down the flow of water and allows water to infiltrate into the ground. So therefore, less water flowing on the surface, less streams cut. Gradient, the steeper the gradient, the higher the density. Because what happens with gradient? If it's steep, water will flow quickly. It'll have more energy. And if it has more energy, it will erode more on the ground, creating more channels. Porosity. The greater the porosity, the lower the drainage density. Now, porosity, learners, is little sort of gaps between the soil, okay, that allows water to penetrate. So if the porosity is high, means there's more gaps between the soil particles, etc. More water will seep in, less runoff, therefore we'll have less stream channels. Then permeability is remember there's a difference here, that's the pore size, the gaps. Permeability is the ability of rocks to absorb water. And obviously, if rocks absorb more water, less will flow on the surface and less stream channels. And what do you notice about this, learners? The emphasis is on infiltration. If the infiltration is less, then more water will flow on the surface and we'll have more stream channels. Of course, there's issues like gradient. Gradient also. If the water flows quickly along the surface because there's steep gradient, there'll be less infiltration, more surface runoff. Already you're trying to see those concepts that we learned we went through at the beginning. Infiltration, runoff. Can you see those things? And we're linking them now. So basically here again, it's about infiltration. All right? That's your main issue here. Okay? That should come out with all these factors. The more the infiltration, less channels. All right? The less the infiltration, more channels. Okay? So we're simplifying and we learn the basics, learners. That's what I say. All right? Give you things like this that I found familiar. Okay? That you look at the basics before you do anything. Then examples of drainage density. I'm looking at these two blocks. They're the same size, eh? And I can say which one has the higher density. Learners, you can put your hands down. I can't see you. I'm just kidding. All right. So we look at which one. And of course, we see here there's a few streams. All right. Here there's a lot of streams and it's the same area. So this is, I'm not saying it's high. I'm saying it's higher compared to this. Okay. All right. Can you see how we can do it in MapBook also? Okay. Let's go on. And I'm sure we're heating up. Stream order. I don't know why this sometimes seems to become a channel. A challenge, not a channel. See, I'm sticking with geomorphology in my comments also. I'm using the word channel. All right. So if I look at one single stream, learners, joined in, but the river still remains as stream order 3 because it's just a single stream. If I have two third order streams joining, then only it becomes 4. Like if I look at this, 1, 1, 1, 1, 2, 2, 3, and there's 2, 3 streams joining, it becomes stream order. Can you see? So it must follow that pattern. Okay, and it's very simple. Okay, when you look at that. And then discharge of a river, very simply, laminar flow, it's smooth flow due to generally level or even riverbed. Okay, it flows smoothly. Turbulent flow, it's a rough flow, generally caused by an uneven riverbed. So when the volume is high, the riverbed is even, and the flow is smooth, that's laminar flow. Now I can ask a question. Where is this generally happening? In which course? In the lower course, it generally happens. Can you see? Because there, it is gentle, volume is high, and there's less obstructions because of the high volume. Turbulent flow, obviously, generally more in the upper course. You will get sections in both where you may get laminar and turbulent. So when you go to a river, don't say, hey man, this person Dave was incorrect. All right, I'm seeing some laminar flow. There will be patches of it in the upper course, and there'll be patches in the lower course, etc. of turbulent. But generally, you will find laminar flow in the lower course and turbulent flow in the upper course. Now we're looking at the next thing, and we're following the exam guideline. Learners, do you notice this? Each section, I've got the exam guideline. I don't want to make this slide fancy because I want to do the simple approach. But why am I focusing on the exam guideline each time? It's because I want to see whether I'm covering the correct aspects according to the exam guideline and whether I'm covering the exam guideline. And sometimes we tend to forget. We just have these notes with us and we just go through these notes and a section pops up. God, why did this section come up? And then you look at the exam guideline, it was there. So important, learners, to look at the exam guideline. So the next section we're looking at is fluvial processes with river profiles, river grading, all right? And we're going to look at various concepts like temporary base level erosion, permanent, distinguishing between graded and ungraded river grading. And under profiles, we look at the cross or transverse, longitudinal profile, the word plan view, and we look at the top, the relationship between the profiles. So we're now starting again to relate the things. So let's get going with this. Okay. A longitudinal profile. You must be able to identify or differentiate between a cross and a longitudinal profile. And that's very simple. The main words here, it's the side view of the river. All right, showing the part of the river from the source to the mouth. So it's a side view. I can't see the full depth of the river. I'm looking at it from the side. Okay, can you see it there? It's a side view. Okay, there's the source, there's the mouth. All right, and you can see your courses, your upper course, middle course, lower course. We realize the characteristics. It's concave in shape, steep at the top or at the source, and gentle at the mouth. That describes it. So we're looking at it from the side. Okay. Then we look at the cross profile. When we're cutting across a river and we're looking at it from here, can you see it? We're looking at it from there. Okay. So there you can see it. It's cut across and we're looking at it from there. So it shows the cross view of a river from bank to bank. I can see the bank here. I can see the bank there. All right. There's my river in between. Simple. Visualize. That is why I'm putting sketches everywhere. You understand? Diagrams, sketches, or pictures so that it's easier. Don't just learn words, learners. Learn to visualize. This is geomorphology. Visualizing the stuff. So I can visualize clearly here of my cross profile. Okay, so what do I see here? Can I see the width? Yes. Can I see the height? Yes. All right. And can I see the level of water? If I had to create water in here, I'll be able to see the level of the water. At what level it is. Is there a lot of water in the river or less? So I can see these three things very easily with a cross profile. So it's a view from bank to bank. Then a graded profile is a smooth concave profile, decreasing in angle, okay, and gradient towards the mouth. Can you see it's smooth? Okay, and it's steep at the top and then decreases in angle. So to make it simpler, all right, I could say that it is a smooth concave profile with no obstructions. All right, smooth concave profile with no obstructions. All right. Learners, I know you're getting a lot of information. At 11, we're going to take a 5-minute break, okay? At 11. All right. My kind producer has that. Hello, learners. Welcome back. I think the director and the cameraman felt that I'm sort of presenting so well. I think they were jealous and they switched the cameras off. Just kidding. There were some technical problems, and I'm sure it's been sorted out. You know, these things do happen. So we're back on track and let's get going. All right, learners, I don't know when the sort of technical problem came in. So you may have listened to part of this longitudinal profile and then part of it was cut off. So I'm going to start off again on the longitudinal profile. So we said a longitudinal profile is a side view of a river. Can you see, you look at it from the side here? Okay, so what is visible? It's showing the part from the upper course or the source to the mouth. And that's what you can see, because you can see the sea here also. Okay, where it goes in. So that is your mouth, the side view. So that is your definition. Now, we can look at characteristics. We can see it has a concave shape. It is steep at the top or the source and gentle at the mouth. So we can see the characteristics within that. Okay, that is your longitudinal profile, the side view. Okay, then we look at the cross profile. Okay, transverse profile. This is the cross view of a river from bank to bank. So what have we done here, learners? We've taken the river, and we've cut across it, and we're looking at it from this point of view. Can you see it? The cross profile. All right. Now, what do we notice of the cross profile? We can see the width, can we? Yes. Can we see the height? Yes, it's 300 meters. Can we see the level of water? If I created water in here, I'll be able to see the level, okay, or the depth of the water down there. So that is my cross profile. Okay, so we must be able to differentiate between the two, all right? Now, a graded profile, and I'm sorry I was gone on to that when there were little technicalities and I didn't erase it. Let's look at the graded profile down here. If I look at this, it says it's a smooth concave profile. Okay, so can you see it's smooth? There's no obstructions. Okay, and it's steep at the top, gentle at the bottom. So even if I want to say it's a smooth concave shape profile, obviously it's a longitudinal profile. Steep at the top, gentle at the bottom. Now, what is an ungraded? Always remember ungraded, like an ungraded road, you find it's very bouncy. All right, when you're traveling. My car won't make it there. The tires will fall off. I don't have a 4x4, but those 4x4s can go over it. Okay, so it's a bumpy road. All right, because it's ungraded. It's not tarred or it's not made smooth. So what does it have? Obstructions. So an ungraded profile, and you notice here, there's obstructions. There's little waterfalls. There's a lake. You understand? All these are obstructions, and they also known as temporary base level. I'm going out of here, base level. Okay, because eventually that waterfall will be eroded edwards, and this lake deposition will happen and it can go. So it's temporary. All right. So it has obstructions. Remember, the river wants this. It's going to try and erode those obstructions to create a new base level, which is smooth. And that's what the river wants in the end, to create this, because it's looking at the easiest part towards the mouth and the sea. Okay? So that's my difference between my graded and ungraded profile. So, graded profile, it's smooth concave profile, steep at the source, gentle at the mouth. It has no obstructions and nick points. I just put this here because that resource doesn't have the writing clear. Ungraded profile has irregularities, obstructions, or temporary base levels along its path. It is not smooth. Can you see the difference there? Okay. Now, that's another skill, learners, differentiating between concepts or terms. You must know the difference. It gives you a better understanding. So let's link these two, learners. Let's link them. Let's link the cross with the longitudinal. Okay. Now, if I look at the upper course of the river, okay, and being steep, the water is flowing fast. So what do we have here? Vertical erosion. And we also have hydraulic action when it's transporting the load. That means the water is getting in between cracks and eroding them. So because it's vertical erosion, all right, it's going down vertical, downward. It's starting to cut and form a full river. You understand? Then it will be deep and steep-sided. Okay? Deep and steep-sided. Pressing too hard and I think I'm going out of it. Okay? So we know the relationship between the cross and there. It's vertical erosion, hydraulic action. You understand? All these factors, abrasion also when they knock against the wall, side of the walls, etc., and erode them. Okay, then we go to the middle course of the river. Now what we have here, we still have vertical erosion. Remember, it's not as steep as the upper course. It's a little more gentle. So we have vertical erosion, and the river is also carrying more load. All right? So we have this abrasion, attrition, etc. happening where the river now also erodes laterally. Can you see it? So there's vertical and lateral erosion that's happening here. Okay? And by the lateral erosion, what is happening to the river valley? It's getting a bit wider. Can you see that, learners? It's getting wider. And then you come to the lower regions where it's very gentle. All right? Now what happens? The main activity here is deposition, where deposition is happening all around. We will have a bit of lateral erosion that's happening, but more deposition here, and together with the lateral erosion, it makes the river valley wide and gentle. Can you see that? So what we have done here is we have then taken our two profiles and linked them. So you must be able to see that. Can you see? Geography is not difficult, learners. It's about making sense of things, about the visuals, and about linking things. Don't learn your cross profile separately from your longitudinal profile. Okay. River rejuvenation. And we're going to look at evidence, okay, or features that are associated with river rejuvenation, nick point, terraces, valley in a valley, all right, incised and trench meanders, and also we're going to look at fluvial landforms, okay, the various ones under this little thing. And you see, once again, I brought my guideline in because I need to see whether I'm covering, and I need to relate factors also. So I just threw this in. This is a waterfall. I'm sure you know by now. All right. What has happened here? There's a change in the gradient. I'm going to talk about waterfalls later. All right. So the water then flows down. When it flows down that steep gradient, what has it received? More energy. It then results in allowing it to erode more vertical. And you see, a nick point is a change in the gradient. So it flowed over this, it received more energy. And as soon as the river receives more energy, it has been re-energized, it has been rejuvenated. Okay, it's a simple concept. All right, so let's look at it here. What's rejuvenation? Occurs when a river's speed and erosive power increases. It's got more energy, resulting in an increase in downward erosion, vertical erosion. So its speed, power has increased, and therefore we're having more downward erosion. It has more energy now. Okay. We can see here, there's a river flowing, and all of a sudden the river has more energy. Can you see how its incised meanders are forming? It's getting deeper. Can you see what it does? Yeah, nothing has happened here. The river is flowing nicely, increasing erosive power. It's incising into that meander. Okay. Characteristics of a rejuvenated river. We need to know that. All right. It includes water that flows rapidly, all right, with the sloping sides that create a steep into the river valley. All right. That's what you've seen just now. Can you see it? It cuts into the river valley. And look at the sides that is steep. So it's actually vertical erosion that is happening. Vertical erosion is significant to understand river rejuvenation. Okay, so it includes water that flows quickly and rapidly with sloping sides that create steep cuts into the valley floor. Okay, reasons for rejuvenation. When the sea level drops, there we have it like this, and then suddenly we find due to things the sea level drops. And now what happens? A steep gradient. When land is uplifted, you've done tectonic forces, etc., that force land up. And there we have it here. And suddenly the land gets uplifted. Gradient again. So it's all about the reasons is how does that change in gradient happen? Increase in the volume of water. You understand? What happens when there's more water? You'll have a faster flowing river with more energy, river rejuvenation. River capture. I'll come to that point on river capture a little later. All right? I know that's one of your areas of concern generally, but I'll come to that later of how river capture also captures the headwaters of a less energetic river and therefore having more water, increasing the volume. But I'll talk about that just now. Okay. So let's start. Features of rejuvenation. The Nick point. Can you see it here? A change in the gradient. Okay, a change in the gradient, which will result in faster flowing water, more energetic. Waterfalls can form at a Nick point, a change in the gradient. If I had to do it on the side, it's like that. There's your Nick point here, a change in the gradient. Okay? You can see it here. There's it down here, and suddenly the gradient changes. That is your Nick point. More energy now. All right, and at your Nick point, you'll also get that headward and backward erosion, because it'll be eroding that way. Okay. So a Nick point is part of a river or channel where there is a sharp change in the channel slope or gradient, a sharp change in the gradient. This can result from an increase in downward or vertical erosion due to rejuvenation. So it forms an increase in the downward erosion because it's flowing over and it's eroding in that direction. Okay? River terraces. Now, as the river erodes, I just want to put it clearly. If you dig a hole, all right, and you start digging deeper, you will find that it gets narrower as you dig down. The top gets wider. Okay, in this way, as there is more vertical erosion, etc., all right, of course, accompanied by lateral erosion, then it erodes downwards, creating sort of steps. Can you see the steps as we go lower down? It's creating new base levels or valleys, and this steps is known as your terraces. Okay, so let's look at, and this is another thing. These things now, like river terraces, will not form if the river is not rejuvenated and creating vertical erosion. Can you see that? Vertical erosion is so important because that's the thing that digs deeper and creates a terrace. So if you see river terraces on a map, you know river rejuvenation is evidence of river rejuvenation. Okay? Then we look at, can you see here? There's the river here. It may not be so clear. Can you see the terraces being formed? Okay, this is a picture, and it's nice to see it because these things do exist in reality. Okay, so river terraces form there. So, what is a river terrace then? When river flowing on the valley floor experiences rejuvenation and cuts into the valley floor, as we showed you. As this process continues, it creates steps at different levels known as terraces. Okay, they are, and I'm sorry, not there, I'm going to put my R there. They are found on both sides of the river valley. So it's cutting, rejuvenation, vertical erosion, cutting into the floor. Okay, and then they found on both sides because we have the steps again. And I'm going to go back here again and show that to you. Can you see the steps as it's cutting? And I'm going to go back here and show you. Can you see it's found on both sides, those steps? Okay. And our next one is an incised entrenched meander. Meaning, and I'm using the same diagram, there's your river flowing, and suddenly it experiences rejuvenation. The flow is faster, it has more energy, and then it cuts vertically down. Can you see? I'm always using that vertical erosion. And now what's happening? It's incising, it cuts deeper into. And now this meander is very deep. That is why we call it an incised meander. Okay. Let's look at the description. Okay. Oh, I wanted to show you this picture. I laughed so much when I actually got it. Can you see how deep it is cut in, this meander? That was the extent. Can you see that? It's cut around, incised, entrenched meanders. So what has happened? An incised or entrenched occurs when a meandering river experiences rejuvenation. And again, it results in vertical and downward erosion. This causes deep incisions and cuts, resulting in incised meanders. Can you see the deep, and I'm going back here, can you see the deep cuts? Therefore, it's an incised meander. Okay. And I'm turning and there we are in a valley. Okay, we can see here what has happened. There's it being created here. There's the river valley, but we've got another valley here. Rejuvenated river flowing in a valley due to increased erosion. So what happens? There's it here. And suddenly there's increased erosion occurring. And all of a sudden, you've got a smaller valley in this larger valley. And that's what we call a valley in a valley. All right, due to vertical erosion again. Okay. And you can see it clearly here, learners. Before rejuvenation, nothing. After rejuvenation, it's cutting in to the old valley and creating a new valley inside the older valley. All right. Can you see? Newly formed terraces begin to cut back and form a valley. So it's like a terrace because it's like a little step. It's a valley. The valley widens through lateral erosion. This process continues gradually, and if rejuvenation occurs repeatedly, new terraces form as well as to increase the vertical erosion. So it's eroding vertical and therefore creating a smaller valley. Okay? As I've indicated here, there's more vertical erosion and a smaller valley forms in this larger valley. Okay. Then your waterfall. These are your fluvial landforms. Where do waterfalls generally occur? They generally occur in the upper course. Okay? Generally, it doesn't mean you can't get them anywhere else. So let's look at this. This is a beautiful waterfall that's formed here. Okay, the main thing about the waterfall is that it's caused by difference in resistance of rocks. We have hard rocks, we have soft rock. So the river flows over the harder rock. Can you see it? And as it reaches the softer rock, it erodes it faster, forming softer rock gets eroded. Sometimes it happens where this softer rock underneath gets eroded and the harder rock breaks off. But what actually happens, it then forms a step in the river. Okay? And when the step forms, the river flows over it, creating a waterfall. Right? The river flows over it, creating a waterfall. We can also take it further. All right, we spoke of the waterfall. Over time, parts of the overhanging resistant rock, because of the erosion, that piece of rock breaks off and falls. Okay, to the bottom. Okay, now the movement of this water results in erosion at the bottom of the waterfall to create a plunge pool. So these pieces of rock fall here, and the movement of the water swirls them. And as they swirl them, they actually dig at the bottom here, creating a plunge pool in that area. Okay. Then rapids, also mostly found in the upper course of the river. Okay, you'll find there's resistant pieces of rock. Can you see? This is less resistant, this is resistant. So they jut out, and then the water flows over it, creating this turbulent flow here. Can you see it? Now we're bringing in the concept of turbulent flow, where it's flowing over that, and it's flowing with a rough flow. Therefore, these are your rapids. Rapids are areas of very turbulent flow in the upper course of the river, where water flows rapidly over uneven terrain. All right. This is caused by rocks of different resistance again. Hard rock, rapid. Can you see it? Rapid. The softer rock gets eroded faster, and the hard rock causes obstruction. Because if the softer rock was not getting eroded, then you won't have this flow. Here, the softer rock is eroded, and it flows, it's smooth again, it flows, it's smooth again, and it flows roughly again. And these are rocks that jut out due to being resistant and has a lower rate of erosion. Then you have your meander. Okay, this is partially in the middle. Hello, learners. Welcome back. I think today is not our day. There's a lot of technical issues and the internet that is actually cutting us off. And unfortunately, I carried on with my lesson and carried on explaining, and you weren't able to see it. So, due to certain glitches, I'm unable to erase this. So, it may not look very professional, but I am going to go through it again with all my little red marks. Okay, so if there's little more technical glitches, etc., please bear with us. I think the most important thing is that we get the lesson done and you learn from it. So while we were cut, I was talking about, and I didn't know you were not there, was the meander. And we said the meander is found in the middle and the lower course. Okay, I'm sorry I'm not able to erase this. The meander is actually loop-like bend. Can you see it? That the river makes in the lower and the middle course. It develops as a result of an increase in lateral erosion. Don't just talk about the river slowing down and therefore it meanders. I've seen this before. It's actually because of lateral erosion. Now, when the river flows, it erodes that point. Can you see it? On the outer bank. And as it flows here, it erodes the outer bank. All right. So what is happening? As it's eroding, and then on the inside it's depositing, it's creating that meander. And as it flows, it erodes. Can you see what it's doing? And it's creating those meander-like bends. Hello, learners. Welcome back. Today is a lot of technical issues. Okay, so we do apologize for that. Our technical staff is working hard out there to try and avoid further disruptions in the lesson. So maybe part of this has been covered, but I'm just going to go over it in case parts were cut when we went offline again. Okay, so I said about river capture. And I said we need to look at, and I'm calling it the overview. All right. Two important concepts you need to know that you've done already. The watershed, which is a high-lying area separating two river systems or drainage basins. All right. So I would look at this where we have a high-lying area, and then we would have one river and another river. This is important to understand river capture. There's your watershed. Or we could have a watershed and the rivers could flow parallel or on the side of the watersheds like that. So we could have two types of movements along that watershed. Okay. Then another important concept you have to look at is headward or backward erosion. All right. Erosion at the origin of the stream channel, causing the origin to move back away from the direction of flow. So we're taking this. If this stream is steep and this is gentle, all right, so this river will have more power and therefore will erode headward, cutting into the other stream. Your headward erosion. That's what we're looking at. Okay, so we have to apply these two concepts which you covered before. So don't think that geography is in isolation, learners. You have to relate concepts in order to get an understanding. The two main things we'll be looking at is river capture and abstraction. And lastly, to understand the river capture, we need to actually focus on the factors of energy. When one river will have more energy than the other, we look at reasons why they would have more energy. And of course, because of this energy, that energetic river will capture the headwaters of the less energetic river. So this is an overview of it. Okay, now let's look at, we're focusing on that energy. Let's look at why one river will have more energy than the other. One of the factors is if the river flows over a steeper gradient compared to the other one, it will have more energy. If a river has less resistant rock compared to the other, means softer rock, it'll be able to erode more than the harder rock. If a river has a greater volume of water, this river has less volume, this river has a great volume. And great volume of water, we learned, will erode more because it'll have more energy. Can you see how we're relating rejuvenation, we're relating drainage basins, all in one? Therefore, it makes us easier or makes it easier for us to understand. Okay. Now let's go. Abstraction. Let's look at abstraction. What is the factor here that will make abstraction, make one river more energetic than the other river? Fast, slow. Let's look at this sketch. This sketch is quite clear. So it's the gradient. Can you see the gradient is steep here? The gradient is gentle there. So because of the steep gradient, what's going to happen? This river is going to flow fast. And as it flows fast, it's going to result in headward erosion. Look at the watershed now. It was there, now it's there, now it's there. Can you see? Because of headward erosion, it has eroded. Now, what has happened to, because the watershed has moved, what has happened to the water, the source, the headwaters of this river? Because the watershed has moved, all this water now flows into this river. And that is abstraction. Okay, it can also be with volume and resistance of rock. So this creates a clear illustration of that. All right, so let's look at abstraction. Occurs when river flows on either side of a watershed. one stream has more energy than the other. This could be through the three factors. Remember, volume, gradient, and resistance. It will erode upstream, and the watershed will move in the direction of the less energetic stream. It's flowing upstream, eh? That's your headward erosion. Don't forget. I'll go back here and show you. Can you see it? It's deeper. It's actually cutting, and bringing it here. And this water is getting captured. All right. So this allows the more energetic stream to capture the headwaters of the less energetic stream. Once again, I'm showing you here. As the watershed moved, what happened to all this water of this river? It went into the more energetic stream. Okay? The size of the drainage basin of the more energetic stream increases. Okay? Because the drainage basin was here. Now it has all these pieces. Can you see it? All these pieces. And now the drainage basin is much larger, with greater volume, with more energy. So remember when we spoke about river rejuvenation, we said when there's capturing of headwaters, rejuvenation is happening. Can you see how it's related here? So don't learn rejuvenation on isolation. It's related to abstraction and river capture. Now we have river capture. Although the processes of the headwaters getting sort of taken by one river, you understand, the more energetic river, it's a similar process, but we divide it into abstraction and river capture. So river capture occurs when a more energetic river captures the headwaters of a less energetic river. Learners, please note, it's two mark definitions. Don't just say when one river captures the headwaters of another river. It must be a proper description in when you write your exams. When one more energetic river captures the headwaters of a less energetic river. All right, so let's look at this little sketch. There's my watershed here, okay? Now, I'm looking at two rivers flowing parallel or alongside the watershed. Now, there's a slight difference if I look at the cross or profile of it. I'll notice that this river is flowing down a steeper gradient. Do you notice that? All right. And this river is flowing down a gentle gradient. So obviously, this river will have more energy. And what is it doing? Because it has more energy, headward erosion is happening. And you see it's cutting through the watershed. Can you see that? It's cut through the watershed. And as it cut through the watershed, eventually what's going to happen? It's going to meet up with the headwaters of the other river here. Can you see it? Now what has happened to the headwaters? It's captured. This is the less energetic stream. This is the more energetic stream. And it captures the headwaters. It takes it away. Can you see that? That is river capture. When the more energetic river captures the headwaters of the less energetic river. Now, learners, you need to know the difference. You just learn labels. E is not the captured stream. It's still its stream on its own. Okay? It's still the stream on its own. It's now lost its headwaters, so it's become a misfit stream, but it is not the captured stream. This piece that has been captured from here, that Hello, learners. Welcome back again. I think we're doing this lesson in series, like your television series, etc. I am praying also it's unavoidable with all these technical issues that are happening. We hope that we can get the lesson now finished. Okay, but it does give you a little break to walk around. So let's get on with our series on geomorphology. I'm going to redo this slide here, learners, because we don't know where it actually cut off. So I'll be repeating myself again. But good thing is we don't have any coloring on this. So we spoke about abstraction. Now we come back to, come to river capture. We said when a more energetic river captures the headwaters of a less energetic river. And I may be repeating again, but I'm saying to you, definitions are 2 marks. Do not write when a river captures the headwaters of another river. You write it in full. When a more energetic river captures the headwaters of a less energetic river. We want the definitions in full. Okay, so let's look at this now. With the abstraction, we spoke about the rivers flowing away from the watershed. Here we look at the 2 rivers flowing alongside the watershed. Okay, now on this diagram, I gave you a little profile, and we can see, let's call this then river B, and river, let's call this river Z. Let's be funny. Okay, we'll notice, if we look at the cross or the profile, we'll notice river B, that area is flowing over a steeper gradient than this area. This area is more gentle. So, because it's flowing over a steeper gradient, it's going to have more headward erosion. So it's going to erode backward. Can you see it? It's eroding backwards or headwards. All right, can you see how we're using the concept? Eventually, what happens? It erodes through the watershed, and can you see here? It eroded through the watershed, and this river, I'm calling it Z, its headwaters now have been captured by river B. Can you see it? And that's your river capture. Okay, can you see the headwaters? It's been captured by river B from Z. Now, I know maybe I'm always saying I'm repeating myself now, but this E is not the captured stream. It's still the stream, but because its headwaters have been captured, it's got less water coming in. Therefore, it starts to dry out and it becomes the misfit stream. I'm just put MF, misfit stream. The actual captured stream is this headwaters that have been captured, and it flows into the other river, B. All right, that is your captured stream. This piece of the river that has captured that is your captor stream. Okay, your captor stream. Right. Can you see it? And here it forms the shape of an elbow. Can you see that? And that's your elbow of capture. All right. This area starting to dry is known as your wind gap. Okay, your wind gap. All right. So those are your features that form, okay, after capture has occurred. Again, it's a rejuvenation because now this river has got more water. It has captured the water of that point, so there's more water there. So rejuvenation is occurring. The volume of river B is larger. The amount of water, the drainage basin is bigger. Can you see it? So all those factors also apply down here. Okay? Of course, you know it. Captured stream, part of the river that was diverted by the captor stream that was stolen. Captor stream is the energetic stream that cuts back and intercepts the other water, the headwaters. The misfit stream, the river that has lost its headwaters as a result of capture, now it's a smaller river. The elbow of capture, not elbow, elbow of capture, is the point where the capture change of flow occurs. You understand? It's taken it and it's taken it to the other river, the elbow of capture. And then the wind gap is the area between the elbow of capture and the Mitchford stream where the water stops flowing and river gravels are deposited. All right, it's that part again, where that part is your wind gap. Okay, and that simply is river capture. That is, this river will have less water over time. This river will have more water, okay, over time, because more and more. Remember, river capture is a slow process. It takes a long time as it cuts through the watershed. Then we do another concept that you seem to have challenges with: superimposed and antecedent streams. Now let's look at it simply, learners. Number one, all right, this is your superimposed. I didn't want to put the explanation because I want to simplify it. Superimposed, all right? What has happened here? These ridges have existed, okay? These ridges have existed. Then layers of soil got deposited. Remember that. And then it formed layers down here of rock. Then the river formed on the layers of rock. So the river is new. The layers of rock have formed, and the river has formed on top of it. Would you remember? River is new compared to the landscape. Eventually, what does this river do? It erodes through the layers of rock. Can you see it? And when it reaches the ridges, can you see the ridges? It also erodes through the ridges. But the beauty part of this is it maintains its course and shape. Can you see that? It stays the same. So two things. The landscape formed by deposition. The river formed after the landscape. The river is new. The river erodes through. It erodes through the layers. It erodes through the ridges, as indicated here, and maintains its shape. Okay, direction. Simply as that. So look at it. Landscape develops before the river. River is younger. The stream network displays the pattern that bears no relation to the landscape. Right? What do we mean by that? Is the flow of the river does not follow the gradient. It has a set flow. And look at here when it cuts through. Can you see it? It's supposed to be moving in the gentle areas, but it cuts through the ridges. And that's not sort of a thing that should be happening with water. All right? The river flows in gorges cutting across ridges. As I showed you there, this is called superimposed drainage pattern. All right? So that is your most important thing. The Vaal River, okay, is an example of superimposed drainage. And don't worry, learners, these notes will be sent to you also. Right, now let's look at antecedent. What's this? The river already exists. Can you see it? It's there. So the river is old, but there's changes in the landscape. Okay, what has happened here, learners? There has been faulting. Can you see it? Part of the rock has been lifted. Can you see it has happened? Or there can be folding also. So what happens when this fault happens? As it's coming up, the river manages to erode. As long as the energy of the river is greater than the amount of the uplift, the river will then cut through any change in the landscape and continue to have its flow. So in antecedent, the river exists, the landscape change is new, but the river manages to have enough energy to cut through or erode that and maintain its shape. That's basically what you need to know. All right? If you know that, you know antecedent drainage. Of course, see, the river developed its course before high-lying areas formed, where the change happened. After the river formed, warping, folding, faulting occurred. The rate of downcutting by the river is greater than the rate of uplift. The river is able to maintain its pattern. That's all. Right. So the river existed. There was change in the landscape, okay? And then there was folding, faulting, it got uplifted, right? And what happened now? As it got uplifted, the river has enough erosive power to erode through it, and it maintains its course. Basically, that's the essence of superimposed and antecedent drainage. Okay? The last thing we're looking at now today is catchment and river management. All right? And there's various things we're going to define it. We're going to look at poor catchment, the importance of catchment, all right? Impact, pollution, overgrazing, strategies to manage rivers. All right. So we're going to go through this with the hope there's no more technical irregularities. Again, can you see we need to know certain concepts to have a better understanding? The first thing we need to know, what is a catchment? All right. The area that captures rainfall, which will drain into the water course or river system. We did that under drainage basins. All right. The area that drains it. Then we also did drainage basin, an area drained by a river and its tributaries, where it drains it. Catchment and management is the balancing the use of conservation of natural resources on a whole of the catchment, of whole catchment basis. Catchment, so it's managing the use and conservation. Please note that when we look at catchment management, it's important to know that we don't tell people, oh, we want to conserve this catchment area. Yeah, please remove yourself from this. It's about balancing the use of it. Human beings are there. People are there. You understand? And of course, we need to avoid them overusing the area and totally damaging. So there has to be a balance between human activities, etc., and conserving the environment. So catchment management is achieved through combined efforts of the community, government, non-government organizations working together towards common sustainable targets to achieve this balance. The balance between humans using the catchment area and conserving the catchment area. And then river management is defined as the management of water resources of a basin or part of the natural ecosystem in relation to the socio-economic setting. So even river management, we talk about catchment, the whole area, the river is found in the catchment area. Also here, we look at managing the water sources, the river systems. But again, when we look at it in relation to socio-economic settings, people living there, etc., how do we limit people damaging the environment in order to conserve the environment? Strategies. So it's about sustainable conservation over a period of time, limiting the use of the natural environment. Okay. Of course, importance of managing this drainage basins or catchment areas. Already you can look at the activities, the natural vegetation, the water supply. We need to protect this. Let's look at why is it important. It stores water and protecting it for future use. Water is a necessity. It reduces discharge and recycle harmful agricultural runoff. When water flows through a natural area, it infiltrates. There's certain parts like your marsh and clays, etc., that actually absorb amount of pollutants. Also, by having the area, just imagine you remove all this vegetation, there's going to be massive runoff. You understand? And erosion, etc. So we need to protect it. by cutting down that. Agricultural purposes, farming needs fertile soil. Industrial purpose, example, use in factories for cooling systems. Okay, water supply. Flood control. If you remove all the vegetation in the upper regions, water will flow quicker and therefore will cause more flooding in areas lower down. All right, maybe it's a settlement that could be flooded. Domestic use by people in their homes. All right, recreation, water sports of the rivers, generation of hydroelectricity if there is any waterfalls, etc. The natural environment, okay, protecting the natural vegetation, the different flora in the area, bird life and wildlife. So it's also about protecting the fauna and the flora of the area. Now, how does the river get polluted? The river gets polluted in various ways. Example, industrial waste from factories, farmers using fertilizers, it goes into the ground, pesticides to kill pests, that so-called pests or insects that are considered pests, that they actually spray certain chemicals so that the agricultural products are protected. And then, of course, untreated sewage. These are some of the main things that pollute the river. All right. And what does it do? It reduces the quality of the water and damages the natural environment around it, both land and aquatic. Aquatic refers to the water sources. You know, if you've got a fish tank, how quickly, if you just change the temperature or add something that's not supposed to be there, your fish will die. Now, let's look at some specific facts according to the guideline. Overgrazing. Too many cattle. Can you see it? Lots of cattle. On one area, they're eventually going to eat up all the vegetation of the area. All right, it's going to leave dry. It's going to result in soil erosion. Look at this. Deforestation. All these forests. This is part of the Amazon, where things are happening and it's causing all that climate change, etc., where we're removing it. Greater runoff, discharge of water, more erosion, etc. So both of them have these sort of effects. Removes vegetation, increases runoff, results in flooding, more erosion, more soil deposited in the river system, reducing the quality and quantity of water and damaging the aquatic ecosystems. More pollutants are added in, more chemicals, etc. All right, it works for both because we are removing vegetation. All right, human settlement. Do apologize if I didn't come as well. All right, now look at this, learners. Number one, there's trees. Okay, and if we look at the infiltration, can you see? Because of the trees, it's slowing down the movement. It's open surfaces. There's more infiltration. Okay. Now look at this, what happened. Okay. This house has been built. Infiltration has decreased. Runoff has increased because there's more concrete surfaces. And as you build more and more settlements, there's less open surfaces. Therefore, you're having more runoff and less infiltration due to the concrete surfaces. So human settlements impact greatly on the management of catchment areas because it reduces infiltration, increases runoff. It also could result in more and more water flooding the lower regions because if there's an urban area here and there's settlements here, and what happens due to concrete surfaces, etc., the water won't infiltrate. It will run off and reach this area here with a greater velocity, causing floods. On the other hand, this settlement could use up more water because there's a lot of people living, so more water usage, less water available in the lower regions, whether it's a natural region, etc. So it could work both ways. Other impacts that we can have on the that humans can have on the catchment area is runoff by building dams. Less water below the dam. If you build a dam here, dam wall, less water here. Urban development reduces infiltration, as we mentioned. Agricultural irrigation reduces water for the natural environment. If you got farms in this area, you are watering those crops. What's happening? Less water for the natural environment. Water projects can reduce water in areas like the Val Chigela scheme, etc. Will take water from one area, reducing water in the other area. All right? Water pollution is a serious issue. You can just see it here. This is found in a significant number of countries where things are just dumped in, sewer, litter, etc. Okay? Now, what does human beings do? They pollute the catchment area and river. They use a lot of water, and this impacts negatively on the ecology of the rivers and the catchment areas. They remove vegetation, which increases runoff. This is basically a summary, all right, and results in flooding and more erosion, as I've discussed earlier on, because vegetation has been taken away, runoff, there's no infiltration or limited infiltration, runoff has happened, more flooding, and if there's more flooding, also more erosion. Strategies to manage the drainage basin. One thing we need to do is improve wastewater treatment. How we treat our wastewater, improve it so that it can be even reused. Maximize wastewater by reusing it for irrigation and purposes of generation. In the dry season, release stored water to keep the ecosystems as natural as possible. When the season's dry, they already got less water. What you do is open up dam walls, all right? Let water go through to the lower regions so they have at least a water supply. Remove alien vegetation, because alien vegetation is actually much stronger and resistant to viruses. So they outlast the natural vegetation and they take over the area. So remove that. Monitor overgrazing. Don't allow. Do things like you've learned before, paddock grazing, where you let them eat. As soon as the vegetation is getting less, you move them to another piece. All right. Proper sewage or sewerage treatment. Do not let sewer get into the water systems. Ensure that you check and maintain it so that it's good enough and that it's there. Renew parts, okay, so that we don't have sewer going. Educate people about the importance of the catchment area and management. Because if you educate people about the importance, they will take more care. And monitor and improve water purification works. Monitor and improve it so that you can see, hey, the infrastructure is getting bad. I need to upgrade it and do my work on that. All right? So I'm just going to go back here. Learners, that actually, I do apologize for all these things, but it was beyond anybody's control, the technical problems, but we have covered the sections that are found in your geomorphology. All right, so I am sure this has given you more oomph to do well. Now, you remember, this is paper 1. And as I mentioned to you when I did the climate presentation, climate and weather will be for 60 marks, and then you'll have geomorphology for 60 marks, and then you'll have map work. And obviously your map work will be rated to geomorphology and climate also, okay, besides the calculations and the GIS. Okay, the interpretation section will be rated to climate and geomorphology. So that will give you your 150 marks for paper 1, which you are writing, learners, on the 11th of November. Of course, your schools will indicate to you the times and to come in. So don't forget, 11th of November. All right. I know you're going to knock that paper because you geographers are top learners. We'd also like to thank the GDE for allowing this presentation. It's highly appreciated. And I want to wish you well in your studies. Learners, remember, study smart. That's what I want to start off with and end off with. Make sure you do past papers. Make sure you take the topographic map and the orthophoto and link it to your theory sections. I know you're going to be a huge success. All right. Till the next time, learners, I wish you all the best. Goodbye.